So I have a problem where it says a sample of 50 motor fatality reports from the Department of Transportation in Tennessee for 2019 is randomly selected. So you randomly pick 50 dead people, roughly, right? You can say 50 dead people because each dead person is represented by a motor fatality report. So 50 people that died in car wrecks. The average age of death for the motorists, 37.1 years old. So if the standard deviation in the age for all motor fatalities in 2019 was 6.2 years, so we're given the standard deviation for all motor fatalities, that's the population there, construct a 95% confidence interval estimating the average age of death for all motor fatalities in the state of Tennessee. So we want to find the average age of death or the mean age of death. Oops, it erased on me, that's not good. Tried to underline and erase. So we want to find the mean age of death. We want to estimate it, right, with a confidence interval. So I want to estimate mean, right? Estimate mean with a confidence interval. So when you're estimating the mean with a confidence interval, the key is, do you know or you do not know the population standard deviation? Do you know sigma? Is it known or is it not known? Well, in this case, notice that the standard deviation is for all motor fatalities in 2019. It's known, right? It's 6.2. So because it says for all, that refers to the population standard deviation. So we have the population standard deviation, it's known. So because you're trying to estimate the population mean with a confidence interval and sigma is known, you're going to use the Z confidence interval rather than, we'll learn about later, a T confidence interval. We're going to focus on the Z. So what's the formula for the Z confidence interval? So mu is unknown, the population mean is unknown. So you're going to find an upper bound and a lower bound to estimate it. So an upper bound, you take x bar, the population mean, plus Z alpha over 2, the critical number for the Z score, times sigma, the assumed population standard deviation, divided by the square root of the sample size n. That's your upper bound, and your lower bound is going to be x bar, sample mean, in this case minus Z alpha over 2, the critical value for the Z score, sigma, the population standard deviation, divided by the square root of the sample size, square root of n. Okay, so you don't know mu. So what things do you know? We'll write the things that we know up here in this little black box. Well, it's going to be black. There it goes. So you know the population standard deviation already. What's the sample size? N. How big of a sample did you take? You took a sample of 50 dead motorists, basically, right? The fatality reports represent the dead motorists, so 50. Sample size is 50. What's the average of that sample? So what was their average age of death? If you read carefully, the average age of death for the sample, right, the motorists there, that's the sample, 37.1 years. So that's the sample average, not the population average, right? We're trying to estimate the population average. And what's Z alpha over 2? What is the critical Z score there? The critical Z score, Z sub alpha over 2. So to find that, you have to ask, what confidence level do you want? So the confidence level right here is 95%. So when you have a 95% confidence level, what Z score do you use? 1.96. That's one of those three you want to memorize. Okay, so we're going to plug all these numbers in and we'll compute. So we'll have 37.1 for x bar minus z alpha over 2, we have 1.96. And then for sigma, we have 6.2. It's going to be on the top of our fraction. On the bottom of our fraction, we're going to have a square root of 50. Square root of 50. So basically, I'm going to take what's in this purple box right here, and I'm going to compute that. So I'm going to have, what, 37.1 minus a number, and then 37.1 plus a number. That should have been a plus. I don't know why I have a minus there. It should be a plus right there, right? That's a plus sign. That was a plus sign above. I just copied it down wrong. So we're going to have that the population mean is between two things. So let's calculate what's in that purple box. 1.96 multiplied by 6.2. And then you want to divide that by the square root of 50. So that purple box, you should get 1.72 roughly. So it's going to be the same here as well, 1.72, it's the same number. So the population mean, we can say with a certain amount of confidence, is in between these two things. So we're going to add 37.1 plus 1.72. That'll give us 38.82. As an upper bound, and as a lower bound, we're going to take 37.1 and subtract 1.72. We're going to get 35.38. But there's our confidence interval constructed. So we say, with a conclusion now, we want to conclude properly. The average, or the mean, you could say, I'm going to say the average age of death for motorist fatalities in Tennessee in 2019. I should say we were 95% confident, right? That's the way you always start it. Always start it with saying you're a certain amount confident. So let's say it properly. We are 95%. That's the best way to say it. Come on. This thing's not working. We are 95, right? That was our confidence level. 95% confident that the average age of death for motorist fatalities in Tennessee in 2019 was between the ages if I can get that to right, there we go. The ages of 35.38 and 38.82 years. So reading that clearly, we are 95% confident that the average age of death for motorist fatalities in Tennessee in 2019 was between the ages of 35.38 and 38.82. So it's a pretty good level of confidence. You only have like a 5